Hello everyone. Welcome to the Introduction to Chemistry course. Here, we will explore why the things around us act the way they do. Chemistry is a branch of science that studies the properties of substances, the changes they undergo, and the laws that describe these changes. Our first unit will help you zoom into daily objects and see the building block of all matter, the atom. What is an atom? Our world is made up of different elements, like oxygen, calcium, and gold, which are found in the air, in our food, and in everything around us. When you zoom in, you'll find that these elements are made up of atoms. So, an atom is the building block of everything around us, and an element is a pure substance that is made up just of one single atom. For example, pure elemental gold. Pure gold is so expensive because it is not made up of any other atoms like silver, because usually in jewelry they use other atoms like silver or copper to put it into gold. But that's why pure elemental gold is made up of just gold atoms, which is why it's so expensive. So pure elemental gold is one single atom of gold, and on the periodic table of elements there is one gold atom. For many years, scientists thought that the atom was the smallest thing because their microscopes couldn't detect anything smaller. However, studies over the years have developed, and now we know that the atom isn't the smallest unit there is. Inside the atom, there are subatomic particles. They are called the proton, the neutron, and the electron. The next couple slides will guide you to learn about the proton, neutron, and electron. This is the atomic structure. We can see that in the center of the atom there is a nucleus. It has protons and neutrons. Protons have a positive electrical charge, and we will talk about what that means later. Neutrons are neutral, so they don't have a charge, and electrons are floating around the atom, so they're not a part of the nucleus, and they are in the electron cloud or electron shell. Proton has a mass of 1 atomic unit and a charge of positive 1. Electrons have a mass of 0 atomic units. They do have a very small mass, but it's so negligible that we just decided to say that it's 0. And then they have a charge of negative 1. Neutrons have a mass of 1 atomic unit and a charge of 0. The number of protons in an atom is called the atomic number, and it corresponds to a number on the periodic table. So you might have seen it a lot in the top left-hand corner. Hydrogen has 1 proton, helium has 2 protons, lithium has 3 protons. They are arranged from the left to the right on the periodic table of elements, but we will talk about that more in Unit 2. All elements have a unique atomic number. That means only hydrogen has an atomic number of 1. Only hydrogen has 1 proton. Ions. In a neutral state, an atom has the same number of electrons and protons, which means a charge of 0. For example, hydrogen has 1 proton and 1 electron floating around, and they both, a positive and a negative charge, cancel out to become one big 0 charge, neutral atom. However, atoms can also lose or gain these electrons, and then they will become an ion. When an atom loses an electron, that means they lose a negative charge. That means they gain a positive charge and become a cation. For example, helium in a neutral state has 2 electrons and 2 protons that achieves a 0 charge. But if helium loses an electron, that means they have 2 protons and 1 electron. The 2 protons make a 2 charge and 1 electron makes a negative 1 charge. 2 negative 1 equals 1. So now helium just went from a neutral charge of 0 to a plus charge, plus 1, because it lost an electron. So I like to think about it as cats because I like cats, so a cat is positive. Conversely, when an atom gains electrons, it acquires more negatively charged electrons, resulting in a negative charge. And this is called an anion. I suppose you can think about it as an onion, and you know how people cry when they cut onions, so it's a negative thing. So if helium, which has 2 protons and 2 electrons in a neutral state, if helium were to gain a third electron, it would gain one more negative charge. So it would have a total of negative 3 and the protons would make it positive 2. So positive 2 and negative 3 make negative 1. So that's why an anion has a negative charge. Next, we need to talk about the mass number and the atomic number. As we remember from 1.2, the mass of one proton is 1 atomic mass unit, and the mass of one neutron is also 1 atomic mass unit. Here is the atomic number, the number of protons, 6. The mass number shows us protons plus neutrons. And usually, in a normal neutral atom, there is the same number of protons and neutrons. So it's usually, if carbon has 6 protons and 6 neutrons, the mass number would be 12. 6 plus 6. Isotopes. Sometimes atoms have a different number of neutrons. That means they are called isotopes. For example, oxygen can have 8 neutrons, 9 neutrons, or 10 neutrons. And we would name the isotopes differently. So this is how we name an isotope. First, we put the element name, which in this case would be oxygen, and then we put its mass number, which is protons plus neutrons. We know that oxygen has 8 protons, and in this case it has 8 neutrons, so the mass number would be 16. So this is named oxygen 16. In this case, oxygen 17, oxygen 18. This is the periodic table of elements. However, this is not the periodic table you would usually see, because usually under each element there would be its average atomic mass, which would be displayed here. But here it's displayed, here is only, you have the atomic number and you have the element name. And you also have the groups highlighted. We will talk about that later in Unit 2. Let's try to complete this exercise with me. And we will need this periodic table from the previous slide to complete this exercise. We are given an isotope with the name of bromine 81, and we need to figure out its atomic number, its number of protons, number of neutrons, and number of electrons. Let's find bromine on the periodic table of elements. This is bromine. We can see that its atomic number is 35. That means that this is the atomic number, and as we learned, the atomic number always corresponds to the number of protons. So bromine has 35 protons. Now let's worry about this. 81 means that the total mass of protons and neutrons is 81. So how are we going to know the number of neutrons? We're going to subtract 35 from 81. 81 minus 35 is going to be 46. So bromine has 46 neutrons. The number of electrons, as we talked about, since this is a neutral atom, is going to be the same as the number of protons, 35. So here we just completed the first row and we completed bromine 81. You will do the same with this and this. And now let's see this notation and how we will be able to complete it. Also, I just want to note that if you don't, so this is the atomic number, this is a mass number. But for this, you don't have an atomic number, but you're supposed to know this from the periodic table of elements. So you will find this element and you will know the atomic number. It's just not displayed here because sometimes it's not displayed on the elements. So let's do chlorine. So it has an atomic number of 17. Let's find it just to check. Chlorine, atomic number of 17. That means it has, sorry, not writing here. It has 17 protons and 17 electrons. Let's calculate the number of neutrons. 35, we have minus 17, which would give us 18. Yippee. Now you guys got the hang of this, so you will complete this exercise. I'm not going to show you the answers. Next, on to Unit 2.